Today we're going to talk about the quadratic function. I'm going to briefly touch upon standard form, and then we're going to focus on vertex form. And vertex form is where we can identify our transformations of the functions. So hopefully some of this will be a nice review. Let's start with the standard form. Standard form is written as ax squared plus bx plus c, where a, b, and c are numerical values, and it's key that the a value cannot equal 0. And the reason that the a value cannot equal 0 is that it would make the x squared disappear, and if the x squared disappears, then it's no longer a quadratic. So this is what we call standard form. We're going to talk about this a little bit later in the chapter. The parent function of the quadratic is f of x is equal to x squared, and the graph of a quadratic is called a parabola, and it's a U shape. Below we have what we like to call vertex form. And the reason that this is called vertex form is that we can actually view the vertex from the translations, which are h and k. So h and k are the new, or is the new vertex, where in the parent function, the vertex begins at 0, 0. A is a vertical dilation by whatever the value of a is. And it changes our y values. If there is a negative in front of the a, then we call that a reflection in the x-axis. And if there's a reflection in the x-axis, that also changes our y values. The b is located inside of the parent function, and anything that happens on the inside of the parent function impacts our x values. So this b is called a horizontal dilation by 1 over b. So we actually take the reciprocal of the number. If it's negative, that's a reflection in the y-axis. So that changes our x's. In our equation, if we see a positive h, then that's a translation left by h. And if we see a negative, it's a translation right by h. So notice that it's the opposite. If we see a positive, it's actually going to the left, and if we see a negative, it's actually going to the right. This is a really important rule to remember. Left and right changes our x values, and then our k value, which is on the outside. When I say outside, I mean the outside of the parent function. That is a translation up by k. So we see a positive, so it does go up. And a negative is a translation down by k. It's really important to take good notes here because we're going to be referring to this a lot. So in the first example, we're just practicing applying our transformations. So let's write down all the names of our transformations. We have a reflection in the x-axis. We have a vertical dilation by 2. So that's on the outside, both changing our y values. And then on the inside, we see a positive 3. So that is a translation left by 3. And that's going to change our x values. We're going to start with our table of values for our parent function. And then we're going to apply our new columns. So we get that reflection, which changes our y's, and a dilation. So we get -8, -2, 0, -2, -8. And we're also going to go to the left by 3. So -5, -4, -3, -2, and -1. And then we're going to plot. And here's our graph. Our vertex is at -3, 0. And this is a maximum. It's the highest point on the graph. So we can graph these and identify our key features, domain, range, if it's a maximum, minimum, and what the vertex is. But sometimes we don't want to go to the effort of graphing. We just want to be able to look at the equation and determine some of those key features. So I'm going to use this example to the right and talk about our key features, and then we're going to look at an equation and find them ourselves without graphing. So our vertex is the turning point. This is our vertex. The axis of symmetry, we haven't talked about this yet. The axis of symmetry is an invisible vertical line that goes right through the vertex. So it's a vertical line. The equation is x equals, and then it's always equal to the number that is our h value. So our translation either left or right. So in this case, x is equal to 2. We either have a minimum or a maximum when we're talking about a parabola. So in this case, we have a minimum, we have a low point. And then we're already familiar with domain and range. Our domain is all the x values, and our range is all the y values. Oh, I forgot to mention, our minimum, we want to say what the y value is. So we have a minimum of -4, because that's the y value at the vertex. Now let's look at the equation below. And without graphing, we're going to answer some of these questions. So our vertex is h and k. So we see a +4 on the inside of the parent function. So that means it's really moving to the left by 4. So -4. And our k value, we see a -5. It is a -5. The axis of symmetry is x equals, and it's the x value it's a little bit easier to see, of our vertex. So a vertical line that goes through the vertex, which creates a mirror image from the left to the right hand side. So that is the same as x equals h. That's where that's pulled from. Since there is a reflection, because we have a negative, that means it's opening down. So we have a maximum, and we have a maximum at -5, which is the y value of the vertex. The domain for all quadratics is -infinity to +infinity. And the range, well, if it's opening down, it's going to be -infinity up to -5, which is that maximum y value.